DDR1. Launched in 2000, running at 2.5 to 2.6 volts, it had 184 pins for desktop DIMMs and 200 pins for laptop SODIMMs. You could spot it by the single notch dead center on the stick. Speeds ranged from 200 to 400 megahertz effective, delivering up to 3.2 gigabytes per second of bandwidth. It powered early 2000s PCs with Intel Pentium 4 or AMD Athlon processors. DDR1 modules typically maxed out at 1 gigabyte per stick, using a 2N prefetch buffer. Compared to older SDRAM, it was a massive leap, doubling data rates, but by today's standards, it was power-hungry and limited. DDR2. In 2003, DDR2 arrived, bringing better efficiency and higher throughput. It dropped the voltage to 1.8 volts and upped the pin count to 240 for desktops, keeping 200 for laptops. The notch shifted slightly off-center to avoid mix-ups with DDR1. Speeds doubled, ranging from 400 to 1066 megahertz, with bandwidth peaking at 8.5 gigabytes per second. DDR2 used a 4N prefetch buffer and on-die termination for cleaner signals, supporting up to 4 gigabytes per module. It powered mid-2000s systems like Intel's Core 2 Duo and early AMD Phenom builds. While more efficient than DDR1, DDR2 sometimes suffered from higher latency and is now fully obsolete. DDR3. DDR3 launched in 2007, a game-changer with a standard voltage of 1.5 volts or 1.35 volts for low-power versions. It kept the 240 pin count for desktops, but moved the notch again for compatibility. Speeds range from 800 to 2,133 megahertz, pushing bandwidth past 17 gigabytes per second. DDR3 introduced an 8N prefetch buffer and flyby topology for better signal routing, supporting up to 16 gigabytes per stick. It debuted in Intel's early Core I series and AMD's FX chips. DDR3 was about 30% more power efficient than DDR2, but by modern standards, it's starting to feel sluggish. DDR4. Fast forward to 2014, and DDR4 took over. It slashed voltage to 1.2 volts and bumped the pin count to 288, with a slightly shifted notch to distinguish it from DDR3. Speed started at 1,600 megahertz and officially hit 3,200 megahertz, though enthusiasts push far higher with overclocking. Bandwidth soared past 25 gigabytes per second. DDR4 introduced bank groups for parallel processing, CRC error checking for reliability, and massive capacities, up to 128 gigabytes per module. It launched with Intel's Skylake processors and became the go-to for AMD Ryzen systems. DDR4 was faster than DDR3. DDR5. Finally, DDR5, which hit consumers in 2021. It runs at just 1.1 volts, still with 288 pins, but the notch shifted again to prevent mixing with DDR4. Base speeds start at 4,800 megahertz and scale beyond 9,600 megahertz, with bandwidth starting above 38 gigabytes per second and climbing higher. DDR5 brought a 16N prefetch buffer, dual subchannels per module for more parallelism, on-die ECC for reliability, and power management ICS built directly onto the stick. Capacities are huge, with server modules hitting 512 gigabytes. It debuted with Intel's Alder Lake and AMD's Ryzen 7000 series, built for next-gen gaming, AI workloads, and 4K or 8K content creation, but it's pricier and can run hot at extreme speeds.